Hello and welcome to the video. Today we're going to look at how mammalian skin has evolved to absorb or attenuate electromagnetic waves. We are also going to explore the skin heating aspect of a high power density 3.6 gigahertz 5G signal, and also as well an active in the wild mobile phone. We'll take various power measurements along the way with the TF2 meter, and we're going to use pork. So I'm really sorry if you're vegetarian or vegan. Yeah, let's get on with the video. Hello, so we got our signal generator set up, and effectively what we're going to do is we're going to fire a load of photons at this meat. And we have our temperature probe there plugged into our meter, so we're going to monitor thermal heating on the skin. Cool, let's get on with it. We're about 24 degrees at the minute, so let's see if this heats the skin of this poor pig. There, you might want to sit this one out, Pepper. Right then, 3, 2, 1. Cool, generating our signal. This signal is 15 times greater than what a mobile phone would produce as well. There we go, off the scale. Obviously the meat is attenuating, absorbing the signal. The pulse you can see is from my Wi-Fi. So the closer we get to the meat, the more it attenuates, but yeah. So, cool, okay. I'll just time-lapse this, but yeah, before we go into the time-lapse, while this is going on before our eyes, so the question is with the electromagnetic spectrum, what the conspiracy theories say about 5G and stuff. You have to think at the which the photon energy density is a magnitude higher than RF, so we're talking, into the not so visible light spectrum like UV, which is right up, the electron volts is super high, it's a magnitude hundreds of times stronger than RF. One of the very obvious things that nobody seems to think about in this kind of community movement of anti-5G people is, well, ultraviolet. What cancer does it cause on the human body? And the answer to that question is melanoma, skin cancer. Not just melanoma, I'm not a cancer expert, but there is other cancers, so type of skin cancer. So, if ultraviolet light only really causes skin cancers of the eyes maybe, I'm not too sure, nose, nostril maybe, but if it only causes skin cancers and the photons or the electron volts are an order of magnitude higher than RF, doesn't that point to the fact that even ultraviolet light cannot penetrate the relative permittivity of human skin? And it's funny, as I'm talking here, it's actually changing the temperature of the meat, so let's get on with the experiment. I'll have to sit back so my body heat and breath doesn't interfere with this. Excellent. Oh, and every now and again you'll see me have to touch this at full power, because it's at full power it does time out, so the signal generator will have to be reset and restarted. and now and again I'll come in and give, just to show you that that is still generating. You know, I've not got it plugged in and I'm communicating it with it via serial or SPI, some magic like that, and just, you know, changing it programmatically. It's actually just plugged clean into a USB power outlet with no data. So at the end of the video I'll do a proof of that as well, but there is no trickery here, as Broccoli always provides is science, facts and truth. And today we are learning more about the dielectric constant or relative permittivity of mammalian flesh and skin, and obviously the thermal heating, which seems to be thermal cooling at the minute, but we'll see how it goes. It's only early days. Cool, so I'm going to give it 10 minutes of that. Then we'll move on to, obviously I'm going to time lapse this, then we will move on to mobile phones and maybe some other like Bluetooth MCUs and stuff like that, and see if they can thermally heat this, but I very much doubt it because the mobile phone will not be off the scale like this is. This is serious power density coming out of this. So yeah, it's about 15 times stronger than the standard mobile phone signal, so great. But am I scared? Am I fook? Honestly, I've stood next to 4 kilowatt transmission lines. This is nothing. Alright, let's do it. Okay, so about 10 minutes has passed, so what we're going to do now is turn off our signal generator just to prove that that is off. That's our Wi-Fi, as I talked about before. Right, so what we're going to do now is we're going to run this further for 10 minutes, because I believe that this room, the sun has literally just come out behind the clouds, and I'm south facing. I believe this room has gone up by 0.3 of a degree, so I'm just going to leave it with it off. In fact, what I'll do is actually power that down completely. So now we know there's nothing, not even any heat, residual heat being generated by, you know, like a voltage regulator or something like that, or a capacitor. So yeah, it's just literally meat. So I would expect, really, if that caused the heating, for this to start to cool down quite quickly. But I do believe that 0.3 degree increase was actually the room. And the room itself was causing the 0.2 to 0.3 degree decrease. So now you can see we're around about 4142. Right, So it's been around 10 minutes of warm down time, but it's actually got warmer. So no, in all fairness, there is a probably, let's say, half a degree variation in the room temperature, but we have been around the 24 degrees Celsius mark. Now it hasn't risen dramatically. The time it really risen a bit more than what it was when the signal generator was on, was when it was off. The temperature we're at now, it seems to be hovering around. Cool, so next experiment is, Mark Steele likes to say this all the time about raising the temperature in the air. In the air. Well, we're going to just do a free air test and see if we can heat the air around our temperature probe. No heating at all from any device. the in-air experiment conclusively, but that's obvious because gas molecules travel around at the speed of sound. The relatively high power density transmission didn't heat the surface of the skin. The mobile phone didn't heat the surface of the skin, whether that be running data or the call. There is no thermal heating. The reason being because these are in the milliwatts. They're not watts, they're not kilowatts. And another misconception out there is like, everyone's like, oh well, 5G and, telecommunications. Them bad, they bad, because you don't understand it. And a load of grifters, because they are grifters effectively. Look at them, they're all monetized. They want money for something. They want to sell you merch. They, have subscriptions and all kinds of advertising revenue coming in. They want to sell you stuff, but they don't have anything themselves to sell, so they make stuff up. To sell stuff, they make stuff up. Because let's face it, they just can't be fucked with gainful employment, probably. But anyway, coming back, so this new 5G technology that they push as being bad, well, it's not. It's milliwatts. Now, terrestrial TV transmitters and DAB radio, most of their towers and relays, even the relays, are in like the hundreds of watts, and they're usually quite close to your homes. You'll see the main transmitters up on hillsides and stuff. Those main transmitters are putting out kilowatts of energy, the average being 4 kilowatts. Some of them, especially in America, are hundreds of kilowatts. I mean, literally hundreds of kilowatts. A fraction of a megawatt of energy at any one time. Not just from one antenna, these are from multiple antenna arrays for different channels, different radio services. And when you see people out in the wild with these, what they are picking up most of the time, you see them holding it as high as they can in the air. What they're picking up is what your TV and radio in your car are picking up, which are these high power density transmissions from radio stations. Not just telecommunications, but all kinds of data links that are putting energy through the air, putting microwaves and radio waves, well, the microwave part, and centimetre waves, meter waves, millimetre waves, putting them through the air at any one time. And the biggest culprit is clearly something we have in our homes. The good old one-eyed monster, or idiot box, whatever you want to call it. That thing that sits on your wall or in the corner of your room. Effectively needs a lot of power density in its transmitters to transmit to wide areas. So stick that in the air all you want. But if you don't do your geolocating and your scouting for these towers, it's impossible. This has a couple of op-amps inside. Those op-amps have no discrimination. So these basically would have like a couple of op-amps inside and an STM32 chip. And the STM32 chip, apart from doing a very small logarithmic math, is just allowing the display as well, and obviously the selector selecting between the different types of op-amp, because each one of these settings has a different type of op-amp. So this has no discrimination. This cannot discriminate between what frequencies are. Now, I have a challenge for the 5G conspiracy theory movement. Go out and purchase a relatively cheap, whether this is an SDR or a handheld all-in-one unit, go out and get a spectrum analyzer, a radio frequency spectrum analyzer. Then go analyze 5G. Now, part of this challenge is you need an antenna capable of receiving the frequency range of 5G. And also, as well, I would like you to get an antenna that is capable of receiving around the 400 megahertz mark. Put that on, hold that in the air, and I guarantee you, you'll get this morning's transmission, you know, the news at 10, whatever time you go out, that you'll get that, or a DAB radio, Chris Moyles on whatever radio station he's on now. That's what you'll be seeing in power density when you attach that particular antenna and look at that particular frequency. You can do this with an SDR radio, whatever, but that's my challenge. Get a matched, balanced antenna for that frequency that's centered around that frequency. Get two of them, one for around the 400 megahertz mark, well, say 250 through 500, whatever, and then get one that's like 2.5 through 6 gigahertz, something like that. Go out and reproduce the results of that. I bet you can't. The reason why I bet you can't is because this doesn't discriminate. It just sucks in everything through those op amps. It's as simple as that. Great round the house, like, you know, testing your Wi-Fi in your home, because you have a lot of material attenuating the signals from the outside. But as soon as you go outside and stick that thing in the air, I guarantee you, you're getting the 6 o'clock news, not 5G. Okay, so thanks for watching the video. Again, busted. I'll catch you in the next one. Oh, it's beautiful. Oh, that 5G. Oh, look at that. I've just got just turn the oven up. Just gonna render that fat off, and oh, that's going in the fridge, and that sandwich material, that really is. Oh yeah.